Welcome to the software testing project for Team Monroe. Abstract. When developing software in computing environments, it is extremely unlikely that any code segment works perfectly the first time. It's because of this that an entire section of the disciplines of software development and engineering focuses on fixing these mistakes and errors in order to achieve completely working solutions that satisfy our logical requirements. This such process, which involves analysis and results in the correction of these problems, is known as software debugging, and it is a skill necessary for the proficient and efficient development of working programs. In this class, we've been tasked with evaluating the performance of a student database system that has been purposefully infested with bugs. The output should be a recovered and restructured, fully functional program. Whether we intend to or not, writing buggy code comes just about as naturally to us as walking. Almost all of us, if not all our programs, contain bugs. In light of that, we found that upon completion of our working program, that intentionally seeding bugs was quite the challenge.
Just like TC was mentioning, debugging the code was not that hard, and of course, just like expected, the harder bugs to find within our code base were the logical errors, since the syntactic ones were pretty much all caught by the compiler. It is important to know that our code didn't compile when we got it, so we had to go in and do some fixes before actually being able to complete any closed box testing. So we work with local data that we generated ourselves. We didn't feel the need of any third-party data application. We also divided our test data into three groups: one that would test each one of the extremes of the code, and one with common data points. We didn't feel the need as well to use any API or GUI automated tests, and we thought that the easiest way to do it was utilizing the Microsoft unit testing framework and also the test functionality from Visual Studio, since some of our teammates um, use Visual Studio for any sort of software engineering, software development, and they were familiar with that. As suggested in the requirements, we decided to utilize the C++ debugger that's integrated with the system. And in order to analyze the code, we decided to use a Clang static analyzer, CPP check, CPP depend, and the analyzers that come embedded in many of modern IDEs. On the other side, on the debugging side, there were many things we had to take in consideration before actually diving into the code. We had to understand what kind of faults could affect the program, understand how to make the programs like this one fail, which were, like TC and I were mentioning before, was not that hard, since we had to complete a similar project and we already knew more or less how the project should look and in what places there could be bugs and therefore fixes. We had to learn how to reproduce such bugs in order to be able to fix them, and also able to isolate origins, understand how the flow control works, and slice the code before finishing all the debugging process. Then we went ahead into the testing part, where we perform two types of tests, open and closed bugs. We cross-check our software against the requirements. We also check for structure and styling errors. Since no documentation was provided to us, we couldn't complete any sort of documentation test, and also we decided to perform stress, volume, timing, and recovery testing to the piece of code that we received. In here and in the next slides, there's a bunch of the bugs or faults that we found within the code we were provided. Some of the most notable were some input, the lack of checking for input in the cases where an integer was expected, and then the user decided to enter a non-integer value, and then the program would crash. That would happen in many places, as you will see later on with Linky and David. The code that we had to fix was really menu based, meaning that a lot of user interaction was expected, and along those menus, the bug of just not being able to not having any sort of check within the input, and just making the program go crazy into infinite loops when a non-integer value was entered. And that was really repetitive along the code. Then other than that, some unneeded while loops, as we can see on box 6. some nested while loops that were not necessary, and then some some integer variables declared as unsigned when they didn't have to, and therefore the compiler was giving us trouble with that. We also had some different aspects of an infinite loop. As like I mentioned before, you can see also here in bug 10, which was on line 186. We, of course, every single time we wanted to change the inputs from the user, the type, we also had to change all the implementation on the different switch cases, because of course they were implemented with integers instead of with characters. So that was another fix that we had to do across the project. We There were also some silly bugs like the logical error where the U number was saved to the email, and the email was saved to a U number, pretty much because the setter methods were setting the variables swapped. We also had a weird case where an I minus minus was in a for loop statement, and then I believe that was within the save method, and therefore the program would go into an infinite loop and wouldn't allow the save method to complete, since the I minus minus was balancing the I plus plus of the for loop, and it was just stuck in the same place. Some other cosmetic changes, like the structure of one of the loops and the information to be printed in order to match the request from the guidelines. Some checks that had to be less than or equal than, or and were inverted from their expected value. And finally, the last couple of bugs that we found are really similar to the ones mentioned before. Things related to range of options, just input checking, or there was a case where, like in bug 28, there was a quality operator, and we actually needed an inequality operator to perform the appropriate check, and therefore have a useful condition in order to continue with the code.
So we're going to go through some examples of things we changed to remove bugs from the code, and one of the most glaring ones was the permission indicator on the fopen function, which was set to write instead of read, meaning every time we tried to read the database information, it would overwrite and create a new file. Detailed examples of ways that we implemented input checking to ensure that any non-integer values wouldn't throw the program into a fuss when the user entered them. So you can never really account for what people will enter as input, even when you specifically specify. So it's best to have your program be able to handle all types of scenarios. So if you want, you can pause and look at these slides in depth to see how these bugs were sorted out. But in general, we replaced all of the input variables with characters or character arrays as opposed to integers. And then if you need to compare them as integer values, you can just convert them later on after you check that they are in fact integers within the appropriate range. And finally here, you can see the group who gave us this program was trying to be tricky. They seeded a double while loop to throw us into an infinite loop anytime we try to run the program, as well as just some general bad programming practices to give us trouble. Alright, so now we're just going to demonstrate that the program works correctly no matter what type of inputs you throw at it. So you can enter characters, you can enter strings, and it'll still work fine. So the first function, the read function, just displays all of the student data. Now, if you try to write student data, once again, you can enter any values, even out of range values. It'll detect and tell you to enter a value in the correct range. So let's try altering the grade of student number 4. Again, any input works. And we'll switch the paper grade to a 4. Now let's try adding a new student to the database. So input checking works. That easy, no bugs.
So I'm going to keep demonstrating the code with the rest of the options. And the fourth one is to delete a student. And once we get into the menu, it will ask to enter the number of students that you want to delete. And before we fix the code, if we tap into other options like anything else other than the options, the code will goes on a very crazy loop. And after we fix it, we can enter like the other options or even letters. It will keep asking you the same question until you get the correct input. So let's try to delete the first student. And once you get the student, it will ask you to confirm if you really want to delete it. And also, like the last one, you can have a typo. For example, if you if you put something wrong and enter accidentally, we will keep asking you until it get the correct answer. And you can type Y as yes, and it will print the rest of the student's information again. And no matter you put the Y or N, it will print it again. And the number 5 is to search a student. You can search student by last name, first name, U number, or email address. So let's try the last name. And the problem is we have to keep the capital letters. For example, we have to have the capital S and to have the Smith, and it will print all the information related to the Smith. And let's try the email again. So if you have summer@gmail.com, it will print the Summer Smith information. And the number 6 is to update student. This one is to update the student information besides than the grades. So you can update the first name, last name, email, or the U number. For example, we can update the U number and get a new one. It will show here, and it will print all the information again. And the last one is to exit, and it will lead to the end of the program. So that is what we have.
This was it for our final project for the software testing course. Thank you so much for your attention. I hope you learned something about this presentation.